So we're going to start out with a little bit of review of the primary trig ratios. Okay, primary trig ratios. This is back to Math 10C. If that's our angle theta, then this is the opposite side. This is the adjacent side. And this is the hypotenuse. Okay, so the three primary trig ratios are sine, cosine, and tangent. So the sine of that angle is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent, right? So you guys may have heard SOHCAHTOA. I think that's probably why we give the three trig ratios in that order, is because of that little mnemonic. But those are the three primary trig ratios. I know that you guys know this and have seen it. On a unit circle, we talked about this as well. Okay. All right, that's a better circle, sort of. Okay, so radius is 1. Okay, if this is the point x, y, then this is our y value. This is our x value. This is our theta. Okay, on the unit circle, the sine of theta is x over 1, or just x. Okay. The cosine of theta is opposite over hypotenuse, y over 1, or y. And the tangent is opposite over opposite over adjacent, y over x. Okay? And in fact, that y over x represents the slope of the terminal arm. If you're centered at 0, 0, rise over run, y over x, that's actually the slope of that terminal arm, wherever that terminal arm may lie. Okay? So we saw this as well. All review so far. Yes? Okay, so now let's talk about some new trig ratios. Now, firstly, before we do that, okay, why do we have 3 of them? Well, if we want to pair up sides, to look at ratios of sides, there's 3 ways that you can pair up 3 sides, right? That's why we have 3 trig ratios. We can pair up these two, or these two. Right? It's like if you have 3 options and you got to choose 2 of them, there's 3 different ways that you can do that. Because in each way, you're leaving one of them out. So that's 3 different ways. Okay? So the trig ratios that I'm going to introduce, it's not anything too novel. The new part is the order in which we choose to pair these up, right? In a ratio, order matters. So the sine ratio specifically is not just about these 2 sides, but it's specifically what's the ratio of opposite to hypotenuse. The opposite has to come first, and then the hypotenuse. Okay? So the 3 trig ratios, the 3 other trig ratios, are called reciprocal ratios, because essentially what we do is we switch the order of like opposite and hypotenuse. Now it's hypotenuse over opposite. Okay? So here they are. The 3 trig ratios are cosecant, yep. Okay. Now we write this as CSC for short, and this is equal to the hypotenuse over the opposite. It's the reciprocal of the sine ratio. So we also sometimes write this, or actually when we think about it, usually, we think about 1 over sine theta. Okay. Now in terms of the unit circle, the cosecant of theta is 1 over y, because sine theta is y. So the reciprocal of that will be 1 over y. Okay? All right, so that's the first one. The second one is called the secant ratio. Okay, and we abbreviate that with SEC. And this one is equal to the hypotenuse over the adjacent, which is 1 over cosine. It's the reciprocal of cosine. Okay? And so in terms of the unit circle, the secant of theta, well, cosine theta is x. So secant is the reciprocal of that. It will be 1 over x. Okay? And then there's one left, which is the tangent, the reciprocal of tangent, and that is called the cotangent ratio. COT. And that's the reciprocal of tangent. So it is adjacent over opposite, or 1 over tan. Okay? And on the unit circle, cotan theta is equal to x over y, because tan of theta is y over x, so it's the reciprocal of that. Okay? Now another important thing to know is that we can write the tangent ratio in terms of sine and cosine as well. Okay? So that's just, you know, and this will become much more evident in our next unit on trig identities. But another sort of, this is not a reciprocal trig ratio, but if we look at, let's say, sine theta over cosine theta, do you guys know what that's equal to? Opposite over hypotenuse over adjacent over hypotenuse. Okay, now I'm dividing fractions here. So I'm going to take the first one, opposite over hypotenuse, multiplied by the reciprocal of the second, hypotenuse over adjacent. Those cancel. Opposite over adjacent. What's that trig ratio? Tan, yeah. Okay, so tan theta is sine theta over cosine theta. This will become quite important in our next unit. Okay, I actually have two, what would I call these? Like mantras in math, particularly in calculus. And the two are, number one, factor. Number two, convert to sine and cosine. Every single trig ratio can be written in terms of sine and cosine because the tangent is a ratio of sine to cosine. Okay? What that also means, though, is that cotangent would be the reciprocal of that, cosine theta over sine theta. So we can write all 6 ratios, all of the ratios in terms of sine theta and cosine theta. Sine theta is sine theta, cosine theta is cosine theta, tan theta is sine over cosine, cosecant is 1 over sine, secant is 1 over cos, cotangent is cosine over sine. everything can boil down to sine and cosine. Okay, so far so good? You guys okay? All right, so here's an example. The point B, negative 1/3 and 2 root 2 over 3, lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. Draw a diagram to model the situation and determine the values of the 6 trig ratios for theta and express in lowest terms. Okay, let's start by plotting that point. Okay, so negative 1/3 is about here. 2 root 2 over 3 would be here. So there's our point. There's our angle. So this is the point, negative 1/3, 2 root 2 over 3. Okay. Now when you're working with the unit circle, it's helpful to think about your trig ratios in terms of y and x. Right? So if you think sine theta equals y, cosine theta equals x, tan theta equals y over x. Let's start with that. Okay? Because we know on the unit circle that the radius is 1. All right, so the y coordinate is 2 root 2 over 3. Okay? Cosine of that angle theta would be negative 1/3. Okay, and tan theta is y over x, or here's another way of thinking it, sine over cosine, because sine is y, cosine is x. So this would be 2 root 2 over 3 over negative 1 over 3. Okay, now that's messy. We don't want to leave our answer like that. So how could we simplify that? Yeah. Yeah, you can multiply it by the reciprocal. 2 root 2 over 3 times negative 3 over 1. And that works out to be negative 2 root 2. Oh, no, just negative 2 root 2. The 3's cancel. There we go. Yes. What did I do? Oh, no. Oh, shoot. What did I do? Where is it? Oh, shoot. Yeah, totally. No, no, no. Why do you guys not stop me? Oh, my gosh. Okay. It's 4th period. I think you guys just enjoy. What's that? There we go. Okay. No, 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 no. Don't assume you're wrong. And I tend to make mistakes with the easy stuff too. Okay. So we got the 3 primary trig ratios. Now we have to get the reciprocal trig ratios. Okay? So I don't think I might have to do this, some of it here and some of it over there. I wrote too big. But the first one is cosecant theta, or the first one I'm going to do, which is 1 over y. It's the reciprocal of sine, right? So that will be 3 over 2 root 2. Okay? Now, if this was a multiple choice test, that's not what you would see as the answer. Or it would be equivalent, but it wouldn't look like that. What's that? What do you think you would see? I'll give you a hint. Look at the denominator. Yeah. Yeah. Most likely, if this was a multiple choice question, the denominator would be rationalized. okay? So to do that, we can multiply by root 2 over root 2, which is 3 root 2 over, this is 2 times 2, 4. Okay, so that's the cosecant of that angle. Secant, reciprocal of cosine. This one's nice and easy. What's the reciprocal of that? -3, yeah. Okay, so there's cosecant, secant. I'll do cotangent down here. Okay, now it is x over y. Now, honestly, if I was starting from scratch, I would use the coordinates, x over y. But I've already figured out the tangent, and it's the reciprocal of tangent. So I'm just going to take my tangent, -2 root 2, this is over 1. I'm going to take the reciprocal of that, 1 over -2 root 2. And then again, here, most likely, the denominator would be rationalized. So I'll multiply by root 2 over root 2. I really like to squish things in, don't I? Okay, and that would make negative root 2 over, this is 2 times 2, over 4. Okay. Honestly, I don't really care that much in written response about rationalizing the denominators. I know I've talked about this before, but I don't get it. I don't understand why we still do it. I understand historically why we do it, why we did it. I don't understand why we still do it. And then when you move on, like very soon for some of you, you're going to be rationalizing numerators too, and that really throws people off because it's like, wait, the way to solve this is to rationalize the numerator? We're not used to doing that, right? So anyway, that's probably what you'd say. I don't care for written response what you do. But on a multiple choice or even numeric, you might even see the cotangent of this angle can be written in the form of negative root a over b. That's been rationalized. Okay. So exact values for all of these trig ratios. So the exact values, again, come from the special triangles. Okay. 30 degrees or pi by 6, 45 degrees pi by 4, 60 degrees pi by 3, or 90 degrees root 2. And then, of course, you can get all of the angles in the other quadrants that have the same reference angles as those ones. Okay, and figure out the trig ratios that way. Okay, now you can always use symmetry to figure out where coordinates are going to be positive and negative, right? In the first quadrant, everything's positive. Second quadrant, y is positive, x is negative. Third quadrant, they're both negative. Fourth quadrant, x is positive, y is negative. So you can rely on that, but a nice little tool to help you remember where the various trig ratios are positive and negative is the cast rule. And this is essentially just a way of remembering where things are positive and negative. Okay, so any angle in the first quadrant, all angles in the first quadrant, all trig ratios are positive. This is all. In the second quadrant, sine is positive. In the third quadrant, tan is positive, and in the fourth quadrant, cosine is positive. And of course, the reciprocal trig ratios will have the same signs. Okay, so for example, if I wanted to know where is secant positive, where would that be? Secant? Secant's the reciprocal of cosine. Oh, maybe, you know what? That's a good way of remembering it. The one, like they switch letters, right? Sine goes with the one that starts with C, cosecant, and cosine goes with the one that starts with S, secant. Yeah, okay, so secant is the reciprocal of cosine. So it's going to be positive in the same quadrants as cosine, which is 1 and 4. Okay? By the way, the reason why cosine is positive here is because remember cosine is the x-coordinate. X is positive in these two quadrants. Okay? The reason why sine is positive here and here is because sine is the y-coordinate. Y is positive in these two quadrants. Okay? And then the reason why tan is positive here is because they're both negative, and it's y over x. So negative over negative is positive. Okay? So that's kind of how it works. Okay, back to this question. To find the exact value of cosine of 135, draw a diagram. So we've got the unit circle, and cosine, so 135 is right here. This is 45 degrees. And this is 135 degrees. Okay? So it is in quadrant 2. Okay, so if we're looking at the cosine of 135, will that be a positive value or a negative value? Negative. Yes, cosine is negative in the second quadrant. What's the reference angle? 45, yeah. Okay. By the unit circle or special triangles. Oh, I get to talk about special triangles here. The cosine of theta r, do you guys know what it would be? Negative root 2 over 2. Yeah. Okay, so you guys look. Oh, sorry. The cosine, you're right, is positive. I'm getting ahead of myself. Cosine of 45 is root 2 over 2. Cosine of 135 is negative root 2 over 2. I caught that mistake myself. Okay, because it's in the second quadrant. So honestly, I don't use this at all, or barely ever. Almost never. What I do when I'm doing trig, when I make a key, for example, for a unit test or a quiz or whatever, I draw those two pictures. And then, because usually we're trying to find the trig ratios for specific angles. As soon as I know my reference angle, I use that angle in the special triangle to do opposite over hypotenuse or adjacent over hypotenuse or whatever I want. And then I can, based on the cast rule, determine if that trig ratio is positive or negative based on the quadrant that it's in. Because the reference angle and the angle itself have the same magnitude for their trig ratios, the same absolute value. Okay? So I use the special triangles to get the absolute value, or the absolute value of the trig ratio, and then I use cast to figure out if it's positive or negative. Okay, so let's do a bunch of these. Here we go. Okay, so look, I want to kind of model for you. Okay, let's see. I'm going to draw 3 special triangles. Okay, now, if you guys are using special triangles, or even the unit circle, whatever you may be doing, at this point, for most of you, you have to do a little bit of work to know the equivalencies in radians. Some of you may already just know, you don't have to think about it, right? And eventually you'll get there. But most of you probably will have to think about this for now. So you may want to redraw it, or maybe just draw it bigger so you can fit other stuff in here. This is pi by 6, pi by 3. Okay, so that's one of them. The second one, I'm going to do this one bigger so I can fit everything in, is the isosceles right triangle, 1, 1, root 2. And this is 45 degrees, or pi by 4 radians. Okay? And then the other thing that I'm going to draw for myself is cast. So now I don't have to rely on my brain to remember anything. I can just look up, and I've got something to work with. Okay? So, this guy. So I personally also always draw the third special triangle, which is not actually a triangle, which I think I showed you guys last class, right? So that third one looks like this. This is 0. This is 90, or pi by 2. And then if that angle is 0, this has no height. So this is also 0, 1, and 1. Okay? All right, so tan of pi by 2, opposite over adjacent, undefined. That's pi over 4. Yeah. Okay. You could also think of tan, pi by 2 on a picture is right here. Okay. Tan is also y over x. Y over x is 1 over 0. That's still undefined. Okay. Cosecant of 7 pi by 6. Okay, let's start with a diagram. 7 pi by 6. Do you guys know what quadrant that would be in? The third, yeah. Because this is 0, pi, 2 pi, right? Half a pi, whoops, and 1.5 pies. So 1 pi would be 6 pi by 6. This is 7 pi by 6. So this is over here. And this little guy is pi by 6. That's the reference angle. Okay? We're looking for cosecant. Cosecant. First, okay, is cosecant in this quadrant, is that going to be positive or negative? Negative, because it's the reciprocal of sine. And sine is negative in this quadrant. Okay? So the cosecant of 7 pi by 6 is going to be the same as the cosecant of pi by 6, but negative. Okay? So there's really not a lot of room here. Okay, I may have to give myself some extra space somewhere. But what I would do here is firstly determine what the reference angle is. The reference angle is pi by 6. It's the angle between the terminal arm and the x-axis. Okay? Then what I would do is figure out, okay, what's the cosecant of that angle? Okay, now you can either work from the sine, which is if you're using the unit circle, most people do that. And then they do 1 over y. Okay, I honestly, I don't know how people do that. It's too hard for me. I work from here, and I'm like, okay, sine is opposite over hypotenuse, 1 over 2. Cosecant would be the reciprocal, 2 over 1. Okay, so that's the cosecant of the reference angle. What's the cosecant of our angle? 7 pi by 6. We've got this cosecant of the reference angle. What's the cosecant of our angle? 7 pi by 6. Should have the same magnitude, but we have to use cast to figure out whether it's positive or negative. Negative 2, yeah. Okay, so I get this, but then I'm also like in Q3, cosecant is negative. So I use the cosecant of my reference angle and cast to figure out the cosecant of 7 pi by 6. Okay, now I obviously am not going to have enough room to do this. Sine of negative 300. I'm going to have to do this way down here. And what's the other one? Sec of 60. Okay. Okay. So the sine of negative 300, if it's negative, we got to go the other way. So where's that going to end up? Yeah, in quadrant 1. And what's this angle over here? 60 degrees. Yeah. So in fact, the sine of negative 300 is going to be the same as the sine of 60 because they have the same terminal arm. And when you're in the first quadrant, you don't have to worry about whether things are going to be positive or negative. They're all positive. So here, this is equal to the sine of 60, which is 1 root 3. Root 3 over 2. Okay, or if you want to, you can think about on the unit circle for the angle 60, what is the y coordinate? And that y coordinate is root 3 over 2. Okay, secant of 60. Secant of 60. So we're dealing with 60 degrees again. If you are in the first quadrant, you don't need to really worry about cast. This is going to be positive. So we just need to know what, and the reference angle is 60 degrees as well. It's the same as the angle. We need to know what the secant of 60 is. What is secant the reciprocal of? Cosine. Yeah. So cosine of 60 is 1/2. What's the reciprocal of that? 2. Okay. All right, let's go back up here. We've got more to do. The cosine of 150 degrees. All right, we're going to rattle through this. Cosine of 150 degrees. What quadrant are we in? 2. 0, 180. It's all good. Yeah. It's a Monday after a long weekend. Okay, what's the reference angle here? 30. Yes. Okay, so here's what I'm going to do. I am going to find the cosine of the reference angle, cosine of 30. Cosine of 30 is root 3 over 2, adjacent over hypotenuse. Okay, now we are in quad 2. In quadrant 2 is cosine positive or negative? Negative. So the cosine, this is Q2. Cosine of 150 is negative root 3 over 2. So really, there's a couple steps. Number 1, I would draw it. Okay? Draw it. Figure out what your reference angle is. Get the trig ratio for your reference angle. Use cast to figure out if your angle is positive or negative. Your trig ratio for that angle is positive or negative. You put those together and you've got your trig ratio. Okay, here's the next one. Cosecant of 240 degrees. Okay, so let's draw that 240 degrees. That's over here. This is 180. So 240, what's this angle? 60. Yeah. Okay, so what I'm going to do is I want to know first what the cosecant of 60 degrees is. Okay, and the way that I'm going to figure that out is I'm going to go up here and say, okay, it's the reciprocal of sine. Sine of 60 is root 3 over 2. So this is going to be 2 over root 3. Okay, so got the trig ratio for my reference angle. Now I'm going to think about cast. I am in quadrant 3. Is cosecant going to be positive or negative? Negative, yeah. So the cosecant of 240 is negative 2 over root 3. I should really put it degrees here, or else we could be talking about radians. Okay. Now, some people like to break this down, and particularly if you're using the unit circle as opposed to special triangles, you may actually need to break this down even further. And before you figure out the cosecant of 60, you may need to figure out what the sine of 60 is, right? So if you need to take that step and figure out the primary trig ratio first to then get the reciprocal, go ahead, that's fine. I find that when people use the unit circle, then they have to take that extra step first. When they have their special triangles in front of them, you can just use opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. It's right there in front of you, and you've got all of those side lengths. You don't have to remember them. Okay? All right, 2 more, and then we'll keep going. Okay? So the secant of 225. Secant of 225. Okay, so this is G. I'm kind of running out of space, but we'll figure it out. Where is that angle? Where does it lie? Third quadrant, right? This is 180. This is 270. It's actually right in the middle. That is 225. What is this angle over here? 45. Yes. Okay, so secant of 225. So first I want to think about what is the secant of 45. Okay, so secant is the reciprocal of cosine. Cosine is 1 over root 2. 1 over root 2. The reciprocal of that is root 2 over 1. Okay, so secant of 45 is root 2 over 1, or just root 2. Okay? Now I am in quadrant 3. Is secant positive or negative in quadrant 3? Negative, yes. So secant of 225 will be negative root 2, or negative root 2 over 1. Okay, and then for H, that's the cotangent of 5 pi over 3. So we're in radians. So where do you think that's going to go? You may need to convert to degrees, and that's totally fine. Yes, it is 300 degrees. Okay, so I don't actually do the conversion. Like, I want to model for you what I do, okay? This is 0, pi, 2 pi. So this is in thirds. So from, like, this is 3/3. So 1, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Okay? There it is. So what we're missing is this little pi by 3. But you know what? You can always, always, always just do 5 pi over 3 times 180 over pi. and you will get 300 degrees. Okay? All right, so if that's 300 or if it's 5 pi by 3, what is the reference angle there? 60, yes, or pi by 3. Okay, so I'm looking for the cotan of 60. Cotan of 60, reciprocal of tangent. So tangent is root 3 over 1. Cotangent is going to be 1 over root 3, reciprocal. Okay, so the cotangent of 60 is reciprocal of root 3 over 1, which is 1 over root 3. Okay, now if I'm looking at this angle, it is in quadrant 4. Is cotangent positive or negative in quadrant 4? Yes, negative. Because it's the reciprocal of tan, right? Tan is negative in quadrant 4. So the cotangent of this guy is negative 1 over root 3. Okay, and I would make sure if you're converting to degrees, your final answer should reflect radians, right? So maybe in between here you have the cotan of 300 degrees equals negative 1 over root 3, but then this is like your final answer. You go back to radians. Yeah. I'm not going to. Because, so the question, if you didn't hear, was do you have to rationalize this? So I'm just going to give you my thoughts on this. Firstly, I'm not going to do it now because you guys have seen it, you know how to do it. I want to move on to other stuff. But my sort of theory is I don't care, except you need to know how to do it if it's a machine scored question. Okay? All right. So what about if we're looking at units and approximate values versus exact values, okay? So you have to pay attention to this because if you're asked for exact values, you cannot round. If you're asked for approximate values, then you could just use your calculator to do that, right? If it's an exact value situation, then it'll probably be one of those special angles on the unit circle, or it might, or that has to do with special triangles, or you may have to be given other information about it, like a point on the terminal arm or something like that, okay? Now, if this is all we have, the sine of 0.5, what unit is that in? Radians. Yes, so now you're going to get out your calculator. 0.5 radians is not a special angle. All of the special angles for radians have some factor of pi in them, right? And you are going to go to the mode. And you are going to make sure that you are in radians. And you're going to go, was it sine? Sine of 0.5. That's 0.479. What did it say to write? It doesn't say. I'm going to write it as 0.479. Okay, 0.5 radians is about, 1 radian is about 57 degrees. So that's like 27, 20, 28, 29 degrees, roughly. Something like that. Okay, that's the sine of that angle. 28 or 29 degrees is not some special angle. The sine of 30, however, we can get an exact value for that. Okay, so if you have your, here's 30, 60, 2, 1, root 3. The sine of 30 is 1/2. Okay, this is exact. This is approximate. Okay, so one indication that you're going to be dealing with exact values is you may be dealing with one of these angles on the special triangle, or on the in a special triangle, or in the unit circle that has a reference angle that's in a special triangle. Okay? So for example, find approximate values for each trig ratio. If we're just looking for approximate values, then we can plug these into our calculators. Okay? So I'm actually going to do these two first. I'm going to do the first and the fourth first, because then I can keep my calculator in radians and not have to flip back and forth all the time. Okay? So sine of 1.92. Where is my, there it is. Sine of 1.92. That is 0.9, how many decimals? 4. 0.9396. Okay, now let's think about why this is positive. It can actually be helpful, like in radians. You know how I keep doing 0, pi by 2, pi, 3 pi by 2, 6 pi, or sorry, 2 pi. I'm thinking ahead of myself, okay? It can be helpful to know the approximate decimals for these values as well. So this is 3.14. This is 1.57. I don't know what that is. What is that one? 3 pi by 2. This is 6.28 radians. What is it? 4 point something? What is it? I don't know. 3 pi by 2. Why can't I? Hold on.
It's like 4.7.
Whoops. I did, on my calculator, I did 3 pi by 7. 3 pi divided by 2. It's 4.71. Yes. Okay. Now, 1.92 radians is here. It's between 1.57 and 3.14. So this angle is in Q2. And in Q2, sine is positive.
Wait. Why is 0.9 between 1.57?
No, this. Yeah. 0.9396 is the sine of that particular angle. Yeah. Okay. I'm going to do this one next. The cotan of 3. So what quadrant is 3 radians in? Yeah, second. Because this is 1.57, 3.14. So it's like here somewhere. Right? This is 3.14. 3 is close to 3.14. Okay, what do you think this is going to be, positive or negative? Yes, it's going to be negative. Now on our calculators, we can't, there's no cotan button. So you have to, on the calculator, enter this in as 1 over tan 3. And that is negative 7.0153. What was it? I can't remember. 7. It was 7. Negative 7.0153. Okay. So now I'm going to take my calculator out, and I'm going to go to mode and go to degree mode. Do you guys, people who have Casios, do you know how to go into degree mode? If you don't, say so, because I can show you right now. You're good? You know how to get to degree? Yeah? Okay. All right. I'm going to hit clear. And so now, tan of negative 500. Now, we can plug this into our calculator and figure out whether it's positive or negative, but to really show why, we need to know where this angle is going to lie. And so what you might want to do here is add multiples of 360 so you can kind of get a sense of what quadrant it's going to be in. Now, one multiple of 360 isn't going to do it. So I'm going to add two multiples of 360. That's 720 degrees. And that is 220 degrees. So I'm finding a coterminal angle that's positive so that I can sort of see where this angle is going to go. And it's going to be in this quadrant here, quadrant 3. Okay. Will the tan of negative 500 be positive or negative? Positive, because in quadrant 3, tangent is positive. So I will take out my calculator now and go tan of negative 500, and I'm getting 0.8391. If I do the tan of 220, by the way, it'll be the same. Okay, so really, you need to find that coterminal angle, or some of you may need to, if you need to justify where the angle is going to go. Okay, because you may not be able to visualize negative 500 degrees very clearly in your head.
Miss Tan, can you call 2232? Miss Tan, 2232. Thank you.
Why can I not remember anything? Okay, hold on. 0.8391. 0.8391. Whew, okay. Secant of 85.4 degrees. Okay, so this is nice. I'm going to do C over here because that's an acute angle. So that's in quadrant 1. Okay, so this is going to be positive. To get the decimal approximation, what is secant the reciprocal of? Cosine. So on your calculator, you have to go 1 divided by cosine of 85.4. Okay, because there's no secant button on your calculator. Okay, I'm going to remember this. 12.4690. 12.4690. Okay? All right. Okay, I think we can finish this up. Okay, so now we're going to solve some very, very, very basic trig equations. We're just going to kind of build up from here. So determine the measure of all angles that satisfy the following conditions. Use a diagram to show the possible answers. So we're looking at the cosine of theta equals 843 in the domain negative 360 is less than theta is less than 180 degrees, and give your answer to the nearest tenth. Okay, so there's a little bit of legwork that we have to do here to figure out all of these angles that are going to satisfy this equation. Okay? The first thing that I like to do is say, okay, cosine of this angle is positive. What quadrants will this angle be in? Yeah. So we're looking at Q1 and 4. Okay? So that's the first thing that I like to do. The second thing that I like to do is figure out what reference angle am I dealing with here. Okay? What is my theta r? And the theta r is always the inverse trig ratio of the absolute value of that. So if it's positive, it doesn't matter. If it's negative, you take the inverse trig ratio, cos inverse of that. If it's negative, you got to make it positive because it's an acute angle. Okay? So theta r will be cos inverse of 0.843. Okay? Now this is in degrees. My calculator is in degrees. So that is, nope, I got to go second. Cos point, is it 843? Okay, 32.5 degrees. Okay. Now I can start to draw a picture and work with the domain that I'm given. Okay, so now what I'm going to do is say, okay, that's 32.5 degrees. But then I also have this angle here. Which, the way that I personally like to do it is start with the principal angle and then add multiples of 360 to each so that it meets the conditions of your domain, right? So what I personally would do is this one's 32.5. Forget about this initially. Don't worry about it. This guy over here is going to be 360 minus 32.5. So this angle is 360 minus 32.5, which is, I think, 327.5. Okay? Yes? Exactly. So now I'm going to work with this domain. Okay? So the 32.5 degrees, that works. Okay? Now what I want to know is, are there any coterminal angles to that one that would also work? And do I have to add 360 or subtract 360? Minus 360. So this is one answer. Another one is 32.5 degrees minus 360, which is negative 327.5 degrees. That's another one that works. Are there any other coterminal angles that work for this 32.5 degrees? That's a different coterminal. That would not be coterminal to this one, though, right? So I'm going to do one at a time. All the coterminal angles that work for this angle in the first quadrant, and then I'm going to do all the coterminals that work for this angle in the fourth quadrant. Okay? Anything else that works for this one? No, because if I subtract another 360, I'm outside of my domain. So now I'll work with this one. So 327.5 obviously doesn't work. But what I can do is take that 327.5, subtract 360. And that gives me negative 32.5. Okay? Now I understand for this example, you don't really need to do that because we already found that reference angle and you know you're going backwards. And I'm not going to ask you to do extra work. But sometimes when you're in different quadrants or working with really weird domains, this is handy to just kind of treat one angle at a time that they have separate coterminal or separate terminal arms, and figure out all of the angles that work in the domain for that terminal arm. Then move on to the next one. Okay? So these are the answers. This guy, and this guy. Okay? Second, sine theta equals 0, and we're working with the domain from 0 to 180. Okay? So this is where we want exact answers. This is where it's helpful to think about your unit circle. Where does sine theta show up? Which coordinate? Y. Yes. So where is y equal to 0? On the unit circle, though? 0 degrees. And then here, what's the angle for this guy? 180. Yeah. Okay. So the angles that work here would be 0 degrees and 180 degrees. Now, one thing that I want to make sure that you guys are aware of and that you just spend a little bit of extra time thinking about. Take a look at your domain and check to make sure that those boundary values are inclusive. Because if they're not, if I just said between 0 less than theta less than or equal to 180, you couldn't include 0 as part of your answer. Okay? So sometimes you come across that kind of thing. Okay. Third, the cotan of an angle equals negative 2.777 in the domain negative pi less than or equal to theta less than or equal to pi. Give your answer to the nearest tenth. Okay, so guys, when I'm working with these reciprocal trig ratios, I always, my first step, figure out the primary one and work from that. Okay, so if cotan of theta equals negative 2.777, tan of theta will be 1 over negative 2.777. And now I ignore this, work from that. Okay, so what quadrants am I going to be in? Two and 4. That's where tan is negative. Okay. Now my next order of business is to figure out my reference angle. The reference angle is the inverse trig ratio of whatever the absolute value of this is. So when that trig ratio is negative, you got to make it positive to find the reference angle. Because reference angle is in quadrant 1. Everything in quadrant 1 is positive. Okay? So this is going to be tan inverse of 1 over 2.777. That's my reference angle. And my domain is in radians. So I'm going to have to switch my calculator back to radians. Now, honestly, I'm being kind of lazy. And I'm just going to use this calculator over here that's already in radians, so I don't have to keep switching back and forth. But the tan inverse of 1 over 2.777 is 0.3456. Okay? So now, what I need to do is say, okay, in quadrant 2, my reference angle is 0.3456. That's my reference angle. Now this is 0, this is pi. How can I figure out this part? The whole thing goes from 0 to pi. That's 3.14. This little chunk is 0.3456. How do I work out what that chunk is? Yeah. Yeah. Subtract. So theta is going to be pi minus 0.3456, which is, I don't know, it says to round to the nearest tenth. So 2.8. Okay? And then I also need one in quadrant 4 that has the same reference angle. So this is my reference angle over here. Okay? Now, here's where you can kind of skip a little bit in terms of looking at your domain and realizing, okay, 0 to negative pi is this way. So this angle is going to be negative 0.3456 or negative 0.3 in to the nearest tenth. Okay, so those two angles would be 2.8 or negative 0.3. Okay, if you wanted to work out the positive, like going counterclockwise, it would be 2 pi minus that. But then you'd have to subtract a multiple of 2 pi to get the coterminal one, which has that negative value. Okay, which is where like the pictures can really help. Okay, so I think this will probably be our last one for today. Cosecant of theta equals negative 2 over root 2 in the domain negative 2 pi less than or equal to theta less than or equal to 2 pi. Give exact answers. Okay. So cosecant theta is negative 2 over root 2. What's the reciprocal? Yep. Yes. And what would the trig ratio be? Sine. Yes. So if this is the cosecant, sine of theta is going to be negative root 2 over 2. Okay? What quadrant will I be in? Or quadrants? 3 and 4. Yeah. Okay? And in fact, if that sine is negative root 2 over 2, what's my reference angle? 45 degrees, and in radians? Pi by 4. So that's pi by 4. This is pi by 4. Okay? Now, we need to go from negative 2 pi to 2 pi. I think what I would do here personally, figure out the positive ones first, then go back and get the negative ones. Okay? So here, this is 0, this is 2 pi. I want to know what that part is. That's 2 pi minus pi by 4. Okay, so 2 pi minus pi by 4. Think about that as 8/4 minus 1/4, 7/4. 7 pi by 4. Okay, this guy over here, that's pi. Pi plus pi by 4. That's 4/4 plus 1/4, 5/4. Ah. Okay, so those are the two positive ones between 0 and 2 pi. To get the negative ones, I have to take each of those, subtract 2 pi. Okay, so theta also equals 7 pi by 4 minus 2 pi. And 2 pi is 8 pi by 4. So 7/4 minus 8/4 is negative 1/4. And here, I have to take the 5 pi by 4 and subtract 2 pi, which is 8 pi by 4. So 5/4 minus 8/4 is negative 3/4, negative 3 pi by 4. Okay, so I have 4 answers here. 1, 2, 3, 4. Okay, and we are going to stop there for today.